Hello everyone, welcome back. So, gonna do a follow-up video on relays and relay operation and some use cases, why you'd want to use relays and what's they're best suited for. Before I hop into this, I just want to thank everyone that has subscribed to my channel. I really appreciate that. I know content is a bit slow right now. Hopefully that will speed up. Starting to get settled in a new place and things are starting to look up. So we'll see how that starts to go. Alright, so I've had a few questions on relays since I made a video, I don't know, had to be a few years ago now. And the most recent one I got, I believe, was from Andy. He asked a really good question that actually inspired this video. So, he wants to know why in a relay do they require two different power sources. So, we talked about that in a little bit on. Before that, I'd like to kind of recap a little bit on a relay, what it is, how it works, all that good stuff. So, we're going to talk about an automotive style relay, generally found in a vehicle for 12 volt purposes, like this guy here. I've just pulled the cover off of him. So they generally look something like this. So a relay is used to control a higher amperage or voltage load from a lower amperage or voltage source. And I mean by that is I want to use a small tiny switch like a toggle switch or maybe a ignition switch to run a motor or headlights or ABS pumps, fuel pumps, electric fans, etc. So if you were to use just a toggle switch straight to like a set of dual electric fans, chances are, unless you bought a really expensive toggle switch, you're going to melt the switch down because the contacts inside, kind of like these guys here, a little contact there, are not rated for that kind of power, so they just melt together and then your switch gets hot and the outside plastic melts. So hopefully you're not at this video because that happened to you, but if you are, welcome. So let's kind of look at the overview. So I kind of drew out a bottom side of a relay, what you'll typically find. So generally an automotive relay has these basic pins. They have an 85 and an 86. These two pins are the coil, and I mean by coil is this right here, this copper area right here with all the windings. That's a coil. A coil is basically just an electric magnet. When it's energized, it pulls a set of conductors right here closed, which creates a connection. Now, that does not create a connection from your power, so we'll say 85 is power, to your load. This only controls the coil and not any other pin. So generally, you'd be powering the coil off an ignition switch or a toggle switch or, whatever. Now, pin 87 is normally normally open. If you look at this relay, you can see there's a gap in there between those contactors and those other pads. That means it's open. There's no connection, so that's normally open. Some relays also have normally closed. And then you have a common. So, in this case, this is a normally open relay. This relay, when you energize this pin, so this was a ground, when I put power to this pin, it closes these contacts. When it does that, it connects pin 87 and pin 30 together. Again, there's no power between these pins. They're just connected. So like you took two wires and stuck them together. And I can kind of demonstrate this a little bit, just to see a live representation. So I just have this GenAce 12 volt RC battery here, 3S battery off an RC car. And watch what happens to these contacts when I energize this coil. Ooh. See how they're closing? It's really hard to touch this one-handed. Try this other one. There you go. Now you can see it. So that's all that's happening in there. I'm giving this coil power. A magnet field is introduced. That just sucks those contacts over. So now let's talk about the contacts itself. So you can see this relay is pretty beefy. It's for an ABS pump, probably a 30 or 40 amp relay. These two wires here are going to these contactors, and on the other side there's two other contactors that go to another pin, which would be pin 87 and 30. So one side of those contactors is pin 87, the other side over here is 30. So essentially when you close those, you make a switch and then you can have an output. So why would you want to have two different power sources? So as I mentioned in the beginning, the main reason you're using a relay is to control a high amperage load or maybe a different voltage load. So from your battery to your coil, or to your ignition to your coil, or to your switch to your coil, whatever you're using, it's going to be a thin gauge wire like this. It's a little 14 gauge. Because it doesn't require much power to activate this coil in here. So what that does for you is that means on pin 87, we could put a piece of 10 gauge wire on there and run a 20 amp motor. But if you were to try to do that straight off a normal switch, you would just melt it down. So it allows you to hook bigger wire from your battery to this pin and then control whatever you're controlling, either like a dual fan setup, a field pump, big old set of HID lights, whatever it might be. So that's really the point of a relay. Now there's also other cases you could use this, and they make different kinds of relays. So this particular coil engages at 12 volts. They make some that are much lower volts, 5 volts. I'm sure they make some that's much higher volts. I know they do like 3 volts. So if you're somebody that does Arduino projects or Raspberry Pi projects or something like that, you could get a 5 volt coil or a 3 volt coil. And then what you could do is you could activate this switch in here with 3 volts from a microcontroller to turn on your refrigerator. So you could activate a 120 volt load at 20 amps. So this gives you a lot of things that you can do with this. It gives you a ability to turn on a big, basically, breaker like light switch essentially off of very little voltage. So you can, control it with a computer, or you can control it with, a 5 volt USB plug. So an example of that is I use computer power supplies to run amplifiers for cars, sometimes for like in my garage. And I have basically a relay set up to turn on the computer power supply. So what I mean by that is I have a regular USB, cord that your phone would come with that I cut the end off of, and I run the positive and ground to the coil of a 5 volt relay, and I plug that into the receiver. So when the receiver gets powered on, it sends 5 volts and ground to the coil. It shuts these contacts. Now, on pin 87 and 30, I have, my power wires for my power supply on those that come into here, and when those shut, it energizes the power supply and turns on my car amp. So that's another thing you can do with it. I don't recommend this, however. If you're not experienced in electrical, I wouldn't be playing with main voltage. I mean, do this at your own risk. It can kill you. But yeah, that's some of the things you can do with the relay. You can pretty much do anything you want with these. You can turn on just about anything with a tiny switch, or like I said, a microcontroller. So in cars, they're used for pretty much everything that's an electric motor, your headlights, heated seats, your heated mirrors, all that kind of stuff. But yeah, again, I want to thank all you guys for subscribing and watching this video. If you do have any questions, hit me up in the comments below. I'll try to answer everybody I can as soon as I can. And again, thanks for all the subscribers. You guys have a good night. Thanks for watching.